Hey everyone, alright, here is 3.1, the ambiguous case with two solutions for using the law of sines. Here's the example problem we're going to work on. Find all possible triangles for which A equals 40 degrees, A equals 11, and B equals 15. So right now, I know B is larger than A. If I go back to that nice handy dandy little blue thing right here, I can say that B is larger than A, so it could be this one, not this one, it could be this one, and it could be that one. So what we have to do is we actually need to figure out where does H fall into this? Remember, H is B sine A. So let's do that part first. B sine A. So we're going to say H is going to equal 15 sine 40 degrees. All right, so let's grab our calculator and let's figure that out. So we take 15. I'm still in degrees. You might want to check that just in case. So we've got sine of 40. And that ends up being about 9.64. Let's get it and use 9.64. So we say about 9.64. So I know that H is going to be less than A, because A is 11, and that's less than B. So we go back and look at your reference sheet, and we have, it's going to be this one, which is what I predicted. So good for you, good for me. All right, so we know we're going to have two solutions. Let's see if we can find both of those solutions. So, setup still the same. You're going to use the law of sines. So let's say that it's going to be 11 over sine 40. No big difference between everything we've done so far. And that's going to equal B, which is 15, over sine of B. Now, I told you in the last video I'm not going to do all the steps this time. I'm just going to cross multiply and get sine B all by itself. So sine B is going to equal 15 sine 40, right, because I'm multiplying these two, and I'm going to divide by 11. So it's going to be sine B equals 15 sine 40 all over 11. All right, and then we can find that, and then we'll just find sine B. Actually, you know what I'm going to do is I'll take this one step further, and I'm going to say B, and I'll write it here. B equals the inverse sine of all this stuff, 15 sine 40 all over 11. That way I can figure out what B is going to equal. All right, so let's get the calculator out, and let's type all that in. So I do inverse sine of 15 sine 40, close my parentheses on the 40, divide by 11, close my parentheses on the inverse sine, and we end up with 61.22 degrees. So let's use blue for that one. So we can say that B is going to equal 61.23. Let's say 61.23, and let's say it's about equal to, I'm going to say that's B1. All right, and if you notice, I've got one solution, and you say, well, where does the other solution come from? Well, let's go here and let's look at the unit circle. And we're just going to use this 30 degrees as an example. So let's say that B was 30 degrees. All right, so I would say that 30 degrees, I would get 1/2, right? If I say sine of 30 is 1/2. Is there anywhere else on the unit circle that is 1/2? We go around and we say, yes, sine right here is also going to be 1/2. So we've got 1/2 here, 1/2 here. So we are going to have two solutions that are possible, right? We could say 30 degrees or 150. Well, how are 30 and 150 related? If I'm going up from 0, I'm also going up from 180 back this way. So it's really going to be 180 minus 30 to get to 150, and 0 plus 30 to get up here. So really I'm going to take 180 minus whatever I get from the original problem over here to figure out what the other angle is going to be. So B1, we go back to here, we're going to say B1 is 61.23 degrees. We can say the other option for B, I'm going to call it B2, is going to equal 180 minus 61.23 degrees. Now we can say, if we look at this one, it's going to be 60 degrees is going to be up here, so it's a little bit more than that up here, and then it's also going to be, well, you can't really see it because I'm in the way, it's going to be about right here on the unit circle. So we're going to have this spot and this spot. All right, so we're going to look at those two. We have 180 minus 61.23, and you're going to get 118.77. So B2 is going to equal 118.77 degrees. So we have our 2 degree measures right there. Now this just becomes two problems that we have to solve. All right. We know what the angle B is. We know what both angle B's are. So now we can say, what is C going to be if we know what B is? So if I want to find out what C is. So it's going to be 180 minus this one, 61.23, and then minus 40 degrees. And I can do the same thing for B2. C is going to be 180 minus 118.77 minus 40. So I should get two different numbers. Let's just calculate those real quick to figure out what my answer is going to be. I'm going to do this one first because 118 is still in my calculator. So I'm going to say 180 minus, oops, I got to make sure I get 180 minus 118.77. I'm going to hit enter, and then I'm going to subtract 40, and I get C equals 21.23. Alright, so this one we say C equals 21.23 degrees. Alright, and then let's go back over here. We're going to say that we have 180 minus 61.23 minus 40, and we get C is going to equal 78.77. Alright, so now we have both of those. Now what we have to do is just solve for the length of C. I'm going to still use A and sine A because B is an approximate angle. I don't want to use approximates if I don't have to. I'd rather use the exact angles. Alright, so let's go ahead and set that up. We're going to have 11 over sine 40 is going to equal, we don't know what C is, but we know that sine of 78.77 degrees. And then I'm just going to set up the other one, seeing as though I have it all here, and we'll just do the problem separately. 11 over sine 40 is going to equal, we don't know what C is, over sine of 21.23 degrees. Alright, so again, let's do this one first. I'm going to cross multiply, get everything out of the way. Oh, I didn't mean to do that. Where'd I go? Alright, I'm back. So it's going to be these two multiplied, and then you're going to divide by sine 40. So what I'm going to do is I'm just going to write it all as 11 sine 78.77 all divided by sine 40 is going to equal C. Alright, hopefully you kind of see how that goes. I'm just solving for C, multiply both sides by sine 78.77, and then you're going to end up with C. So let's get the calculator out, and let's do it. 11 sine 78.77. I always get that. I'm going to divide it by sine 40. That way I don't make any silly mistakes. And I get 16.79, let's say. C is about 16.79. And that is going to be about C. Alright, good. Now let's do the exact same thing with the other one. If we go back here, let's just multiply by sine 21.23. And you should get 11 sine 21.23 all over sine 40 is going to equal C. Alright, good. Now let's just plug that back into the calculator. We get 11 sine of 21.23. Get that answer divided by sine of 40, and we should get an answer for C to be 6.20 if we round up. So 6.20. You can say 6.20 is about equal to C. So my possible triangle lengths would be 6.20 for C. My angle for B would be 118.77. My angle for C would be 21.23. If I'm talking about the other triangle, maybe if I use red, that might help kind of identify it. There's my length. There's my angle. There's my angle. So my solution for the other one, there's the missing angle. There's the third missing angle. There's the third missing side. So now we have two triangles that we'll find the solutions to. Alright, so there is our ambiguous case with two solutions. Here is your example coming right up here. Find two triangles for which A equals 12 meters and B equals 31 meters, and the angle A is 20.5. Notice I did tell you it's two triangles, so you know that it's going to be a two-solution ambiguous case. All right, good luck. And here is your trivia question. What Iowa city did David Letterman once designate, quote, home office for his show because it was the only major U.S. market not carrying it? Good luck.